Hey, everybody. Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green, and this is another of our hour-long live episodes. And my guest today is Mark Rendle. Hey, Mark, how are you?
I'm good, thanks. How are you?
I was just thinking while all that groovy music was going on that instead of having starting soon, we just have the two guests going like this
Just
for
bobbing
two
our
and a half
heads to
minutes. And then
the.
we could also have all of the viewers come in and we could have like this, 10 by 10 grid of everybody going like this to that snappy music.
That would be better. Next time. Next time we do that.
Next time. So our topic today is gRPC, which we've covered this on the show before. It's been covered certainly on .NET and .NET Conference, and you may have seen it at Build. We understand that's where a lot of the investment's going, fully supported in .NET. And I think what we want to talk about today is, review what is it, why was it invented, what are the scenarios that it hits, and then particularly for WCF developers, what is happening to WCF? Is it going away? Is it being replaced by gRPC? Should I start all my new services with gRPC? Should I convert all my existing WCF services? Should I just leave those alone and do gRPC? Can I mix and match? How do I use this thing? All in 1 hour.
All in 1 hour.
All in
and
1
some
hour.
demos. And some
And
demos
so
as well.
to cover that, I thought what we would do is bring on Mark, who literally wrote the book on the subject. So let's see. Here's the book, and there's the URL, which we will include in the show notes. So don't feel like you have to write that all down now. But Mark wrote a book on gRPC for WCF developers.
Yeah.
And so I thought this would be a great opportunity to learn more about this.
I really have to point out, by the way, that my wife was co-writer on the book. And she basically made the difference between me splurging things I know onto paper and it actually being a book and something that you could read.
Okay.
So
you're saying that we should have had her on the show too?
No, she knows nothing about gRPC or WCF. She just knows a lot about writing books.
Okay.
But yes.
All right.
So shall I just
Yeah.
answer all your questions? Yes, no, yes, yeah. So yeah, this all started back when Microsoft, Scott Hunter, I think it was, announced that the next version of .NET after .NET Core 3.1 would be .NET 5.
Mm-hmm.
And so that people weren't getting confused between .NET Framework 4.8 and .NET Core 4.0
Right.
and whatever. And at the same time, he kind of went, with .NET Core 3.1, we're drawing the line in the sand. So everything that's now in .NET Core, so ASP.NET Core MVC, Windows Forms, and WPF, is coming across. Entity framework, all those sorts of things. But these things will not be coming. And he listed Web Forms, Windows Workflow Foundation, or Workflow Foundation, I think it ended up being called because WWF was taken.
It was called Windows Workflow Foundation, but the abbreviation was WF.
And WCF was not going to come across. Yeah. And all of these things caused wailing and gnashing of teeth because,
of course.
And understandably, Microsoft spent 10 years telling developers that the right way to write distributed systems in .NET was to use WCF.
Right.
And then they said, no, it's not anymore. It's this new thing, gRPC, that you've never heard of. And I'd done a little bit of stuff with gRPC here and there. And so I started blogging about what it was going to be like and doing some performance comparisons between .NET Core, gRPC, and WCF.
Mm-hmm.
And then Microsoft got in touch and said, hey, have you ever written a book? And I said, no. And they said, would you like to? And so, yeah, I dug into it sort of properly, deeply, and really since that point, my mission in my community engagement work and everything, my blogging and speaking at conferences and everything, has been to try and help people who have these huge investments in .NET framework, the full fat Windows only one, to see ways off that. And so that's a continuing work in progress. But yeah, gRPC is essentially designed to solve the same problems that WCF solved, but with some differences that are probably quite important.
And this is not the first time that a technology has been matured or replaced. And, this happens throughout. And, the first question you ask yourself is, why was this invented? What problems is it solving? Do I have that problem? And will my existing code still work? The answer, which is almost always yes. So then the question is, do I convert? Do I start new? So
yeah,
I don't think this is any different, right?
No, not really. I mean, when .NET first arrived, the RPC story was .NET remoting, and then that was deprecated in favor of WCF. And now WCF is being deprecated in favor of gRPC. And when WCF first showed up, the problem it was solving was how can .NET applications talk to other applications written in Java, I think was probably the most common interop story. And in 2006, the answer to that was SOAP, Simple Object Access Protocol, which basically took XML and made it even more verbose.
Oh my God.
And documented it with even more XML that was even more verbose than the verbose XML that was in the SOAP.
Yep.
And that was how things talked to each other. They ran on HTTP servers and they sent SOAP messages at each other.
I was in marketing back then, and I remembered, doing the keynote demo. See, look at how easy it is to build an ASMX web service, and it's so easy. And now, of course, if you want to do troubleshooting, here's the SOAP that gets sent across, and everyone's like this. But you don't have to worry about that. But let's close that and move on.
That was the nice thing about WCF, was that it let you focus on writing your C# code, writing interfaces and implementations of interfaces. And then it just generated all that nasty SOAP, all the WSDLs and everything were just generated for you. You didn't have to worry about actually defining your schema in XML.
So now we're on to, we could probably talk history all day, but let's fast forward to the present.
So fast forward to the present, we got gRPC. Which came out of Google, and the intention was to solve basically the same problem that WCF was doing, which was distributed systems. And Google were kind of the pioneers of the distributed system. Their whole MapReduce was sort of thousands of servers running queries and then shrinking them down, and then another bit runs on another server and whatever else. And at that scale, you need the communication between the servers to be as efficient as possible. And you need that in two ways. One is it has to be very efficient for the nodes, for the CPUs in the cluster to encode and decode the information. And the other is that it wants to be as small as possible when you're sending it over the network. And so their answer to make the serialization and deserialization fast and make the messages small was Protobuf. And a lot of people who've never used gRPC may very well have used Protobuf. You can actually use Protobuf as the message format in WCF if you're concerned about serialization and so on. And internally, Google were using Protobuf with a sort of hand-built RPC framework called Stubby. And Stubby talked over raw TCP sockets and handled framing and every package sizes and all that sort of thing itself. And then HTTP2 came along, which actually was also Google's invention, because it was basically Spuddy, which was Google's enhanced HTTP, but that got standardized at HTTP2, and that had almost all the capabilities that Stubby had been layering on top of raw TCP sockets. And so Google went, let's re-implement Stubby using HTTP2 as the protocol. And since HTTP2 is open and runs over the internet and everything, let's open source this and make it available to everybody. And so gRPC was born, and the G does not stand for Google. It doesn't stand for anything at all. It's just a G.
Okay, that's why it's lowercase.
So that's why it's lowercase. Yes. I think there was a thing where different releases, the G stood for different things. So there was like glorious RPC and ginormous RPC and whatever else. But it is essentially solving the same problem that WCF was solving. The really great thing, in my opinion, about gRPC was WCF allowed your .NET code, whether it was a client or a server, to talk to other languages and other frameworks and other platforms. But it did that using SOAP. SOAP, I did a comparison once, and the SOAP envelope necessary to send the single value 42 is close to, if you send that as the response to a SOAP message with a few sort of bits of metadata and stuff, it's close to a kilobyte of XML for essentially 2 characters. And then WCF also had NetTCP bindings. And NetTCP bindings were just astonishingly fast. The serialization, the deserialization, and the sending between servers. NetTCP was basically Stubby. It was just Microsoft's internal implementation. The problem with NetTCP was it was .NET only. So if you had a .NET client and a .NET server, then you got all the speed, performance advantages of NetTCP. But if you wanted interoperability, you had to go with SOAP. gRPC gives you the best of both worlds. So the format and the network message size is very similar and very close to NetTCP, but gRPC is available for C#, C++, Java, Rust, Go, Python. There's a standalone Kotlin implementation now, Swift, Objective-C, and some of these are first class. So they're part of the gRPC organization on GitHub, and they're maintained and managed by the core team. And then there are fully independent open source implementations of gRPC, but which are compatible. So gRPC is both a standard and a technology.
Cool.
So yeah, it's the best of both worlds. And I think in 2006, the whole kind of multi-platform polyglot thing wasn't quite so important. Companies quite often we are a .NET shop, and then that company over there would be a Java shop. And maybe if 2 shops needed to talk to each other, then WCF and SOAP came in handy. But in this day and age, we're building very different systems, and distributed systems are becoming the norm. We call them microservices now because somebody needed to sell a whole load of consultancy, and so they had to come up with a new name for something. But it's very, very common for medium-sized, large enterprises to have dozens of teams working on individual services and using the tools that are appropriate for them. And so you're going to get some people doing data science with Python. You're going to get some people doing desktop development with .NET. You're going to get some people doing servers with Scala or F# or .NET or, whatever. Things written in Go, and Rust is becoming more and more popular. And so this idea that you need something that can talk multiple languages is actually much more important today than it was 15 years ago.
So Ganesh wants to know, isn't that basically what REST was doing? How do you think about gRPC versus REST?
So gRPC, REST is great for certain kinds of APIs. If you've got a public API, so like the GitHub API or the Twitter API or something like that, the Twitch API for those of you who are watching on Twitch, which I've been exploring recently, then REST, or basically JSON over HTTP, is absolutely fine, and a very, very sensible way of building that kind of thing. It's when you've got two services running beside each other in a data center, whether they're microservices or just, distinct services from each other, and they need to talk to each other. Or when you get to the point where you've got 100 services and they do all need to talk to each other. And the two issues with JSON over HTTP, because I'm reluctant to call it REST, because most of the time it's not REST, it's just JSON over HTTP, and that's fine. There's nothing wrong with that. But serializing and deserializing JSON is not, it's more CPU and memory intensive than Protobuf. And sending it over the wire, it is bigger. And so the network messages are bigger. And so your request time and your latency goes up. And essentially you're just doing this. You need a way for those two services to talk to each other. And ideally you shouldn't care what it is. But the more efficient you can make it, the more services you can run in a smaller, denser, cheaper cluster. And so that's one of the cases where gRPC really shines.
Cool.
The other one where it's seeing uptake is some games use it. So you wouldn't use gRPC for your game's netcode for like multiplayer Fortnite or something like that. But for games which are sort of asynchronously updating leaderboards and that kind of thing, and also for mobile development, because it uses less bandwidth and it's easier on the CPU, which means it's good for the battery on your phone, and it's good if you're out somewhere in the middle of the country and you've only got sort of 2.5 Gs instead of 4 or 5. So yeah, but certainly for public APIs, JSON over HTTP is still probably the easiest one for people to get to grips with.
All right, let's see some code.
Let's see some code. So I have got, if I can find it, so it's May the 4th, and so I tweaked one of my demos to be Star Wars themed.
Excellent. It is Star Wars Day after all.
It is Star Wars Day. I'm wearing my Star Wars t-shirt as well.
There we go.
JavaScript. So yes, this is the Death Star warehouse, basically, where people order the supplies from that they need to build the Death Star and everything. And so this is a WCF service. We've got our service contract here, which is our interface. We've got two operations: get supplies, which returns an IEnumerable of supply item, and order item, where we pass in a code and a quantity and a required date, and it passes back the date that it says it's going to deliver it. And then we have our implementation of that in here. And we have our data contract here, which is just a code, a description, how many there are available, and what the price is. And this is all, at the moment, this is all in a single project. And we've got a data directory here, which has got some data classes inside it. So we've got item in here, which is not the WCF data contract, because if this was a real application, you might be using something like Entity Framework or similar here. So you would have to be mapping from your entity framework objects to your data contract objects. So I've kept that sort of thing here. And then we just have just a simple in-memory implementation. So we don't have any external dependencies. And you can see here that we've got lots of blasters, 6 turbo lasers. We're out of exhaust port security covers, apparently. That shouldn't be a problem. And we're also out of lemon pledge. So yes, and then we have a console application that references this service. So that's got the connected service reference to Death Star Supply, and that's using the WSDL from the WCF project to generate a client to talk to the WCF service. And so if I run the Death Star Supply application, and we get that empty browser popping up, and then if I go in here and I run the client console, I can't set these as multiple startup projects because you sort of put a task.delay in, but it's easier to just do it like this. And so that basically says, okay, we've got blasters and we've got huge turbo lasers. So I'm going to say order 6 huge turbo lasers. Those are going to be delivered tomorrow at this time. And then I'm going to order an exhaust port security cover, and I only want one of those. And we're going to get an exception. And then that exception is going to fall through to here and say item unavailable. And then I press Q and I can quit. So that's very straightforward. And so what I wanted to talk about was the process that you would go through with this very simple application, but with a larger application as well, to migrate this to gRPC and turn it into a .NET 5 application.
All right.
So the first thing I'm going to do is this data thing in here. I think it's important to remember people think they've got an enormous investment in WCF. And in most of the cases where I've talked to people or looked at things, they haven't actually got an enormous investment in WCF. They've got an enormous investment in C# or VB.NET and the .NET framework. But really, the bit of it that's WCF, it's just the shell. And so what you're saying is take all your nice business logic code and your data access code and everything, take it out of that WCF shell and put a new gRPC shell around it.
What people really have a good understanding of is the WCF plumbing that wraps their code, how to create a new one, where to put the code, how to get it running, how to call it. But you're right, the actual code, the business logic, the data logic, you can, for the most part, in many cases, just lift and shift over to a new shell, if you will, or new frame.
And ideally, your service contract implementations like this one here should be, even if Get Supplies was actually going off and talking to 3 databases and an external API and doing all that sort of stuff, your operation contract methods in your WCF implementation should be a few lines long, because they should be wrappers around other classes that are implementing things. So it might be time for some refactoring.
Okay.
If you've got 1,000-line operation contract implementations, then think about doing some cleanup and some refactoring, same as you would with an ASP.NET Web API service or anything really. So I'm going to add a new project to my solution, and I've got class library down here. Visual Studio switched at some point and started putting .NET Framework, because it used to put core by things, and then console app would just be a .NET, and then they switched, and now they're kind of going, no, this is a .NET Core or .NET 5, and this is Net Framework. So I'm just going to create a class library, and I'm going to call it Death Star supply dot data. Yeah, let's target Net 5.0. Actually, no, let's not target Net 5.0.
No.
We can change it very easily. We're going to go in here and we're going to change it to Net Standard 2.0. Because that means that I can cut these out of here and paste them into here and get rid of that. And so now, I mean, this isn't doing anything particularly clever at all. But for the most part, if you've got lots of ADO.NET talking to your database, or if you're using Entity Framework 6 point, whatever the latest version of Entity Framework is, most of that code, nearly all of that code, will still work in Net Standard 2.0. The latest version of Entity Framework 6, the old full fat Entity Framework, supports Net Standard 2.0 or 2.1 specifically to support this scenario where you're moving things across. But yes, so now this is a Net Standard library, which means it'll work with .NET Core, .NET 5, and .NET 4.7.2. It will not work with .NET 4.6.1 in a couple of edge cases. So if you're on Net 4.6.1, then probably upgrade to 4.7.2 or 4.8. And then I can add a reference to that library to my WCF application, and then everything in here should still work okay. Yep, build succeeded. So now I've pulled that out. Now I can create a gRPC application to wrap around it. So we're going to go for an ASP.NET Core gRPC service, and we're going to call it Death Star Supply gRPC. And I will use Net 5 for this. And that's going to create an ASP.NET Core gRPC application. And it's worth talking a little bit here about gRPC as it relates to .NET. So gRPC has been available on .NET for a very long time. Google have been shipping gRPC.core library for .NET that is a wrapper around the native C++ implementation of gRPC. What Microsoft did in the .NET Core 3 timeframe was they completely re-implemented gRPC on top of ASP.NET Core and on top of Kestrel and the ASP.NET Core hosting application model. So it is pure managed code end to end, and it sits nicely in a standard ASP.NET Core application, as you can see here, because this looks like an ASP.NET Core application. We've got a program.cs, and that's doing exactly the same things. Create default builder, use startup, and then in startup here, this looks just like an ASP.NET Core startup. We've got configure services, and we add gRPC. And then in our use endpoints, we just map a gRPC service. And everything that works as part of the ASP.NET Core pipeline works for gRPC as well. Authentication and authorization is done the same way. You can see the default code here. If the greeter service doesn't catch something, then it falls back to sending this message to say, hey, this is a gRPC service. But if you want, you can have gRPC and, say, Web API controllers or Razor pages. You can stick them all in the same application. It'll be a maintenance nightmare, and I wouldn't do it, but you can. So yes, and then the standard code here, the sort of hello world thing, has created this greet.proto for me, which I'm just going to edit. And there's an implementation here, and we'll come back and look at that later. So I'm going to rename this greet.proto to supply service.proto.
And what is the very short description of what a proto is? Is it an interface? Is it?
Yeah. So the proto, it serves two purposes. It is how you define. So the proto is essentially the equivalent of the service contract and data contract attributes in WCF.
Okay. Yep.
Yeah. So it's how you say, this is what my service is going to look like. This is the data that's going to be sent backwards and forth.
Okay.
It's also the WSDL. It's also the file that you share with consumers of your service to say, hey, this is how you generate a client to talk to my service. But
so it's not necessarily doing anything new that we're not used to. If we've been doing WCF, it's just doing it in a different manner.
It's doing it in a different manner.
Is that an oversimplification, or is that literally true?
Sorry, I missed what you said.
Is that an oversimplification, or is that pretty much true?
It's pretty much true. One of the key things with gRPC is it comes from a language agnostic place. And so with WCF, it was kind of designed for C# and VB.NET developers. gRPC is designed for people who want to create services in any one of a couple of dozen different languages, and it doesn't favor any of them. So the Protobuf language, which is what this is a completely standalone language, and it's really not very complicated. So I'm just going to change a couple of things in here. So up at the top here, we say syntax equals proto 3. Protobuf still supports version 2, but you would never use that for gRPC. So syntax equals proto 3, but you have to have it. It doesn't default to anything. And then we have our package name. So the C# namespace, that is only going to affect the way it generates C# code. It's not going to change the way the service appears to clients or anything else. The package name is part of the service's identity. So the package name we're going to call Death Star Supply, like that. And then we've got our service here. And so this is like the equivalent of a WCF service contract. But it's literally just going, there's a service, it's called supply service, and it's going to have these methods, and then we're going to have some messages as well. And so if we refer back to our service contract here, so we've got a get supplies method that returns an IEnumerable of supply item. So we're going to say RPC get supplies, and then we say what argument it takes. It doesn't take any arguments, but I'll come back to that in a moment. And then it's going to return something as well.
Okay.
Now, gRPC cannot have a parameterless method. It has to have a method name, a parameter, and it can only have one parameter. And it also always has to return something.
Okay.
So we're going to declare a couple of messages. We're going to have a message get supplies request, and we're going to have a message get supplies response. Get supplies request is going to be empty. I'm just going to specify that in here, and then I'm going to say it returns a get supplies response. And then what we need is a message supply item, this, and we'll just go and check what's over here. So we've got a code description, which are strings, an int, which is how many are available, and then a decimal, which is the price. So we're going to have a string code equals 1. Now, notice that with code there, I have made it lowercase. The naming conventions for Protobuf, they're not compulsory, they're not enforced by the compiler, but they are very important. If you use snake case, so lowercase with underscores between words, then the compiler will generate the right property names for different languages. So for C#, it will generate Pascal cased property names. But for Python, it will just leave the snake case in there. For languages that use snake case, it will just leave it. So it's a good idea to stick to the Protobuf naming standards.
Okay.
And you'll also notice that I'm giving every field here a number. And that is actually part of the serialization. So when you're working with messages, you're just working with Protobuf. There's no gRPC in this bit. And Protobuf uses the ID of the field. So code is ID1 and description is ID2. It uses that in the serialization and deserialization so that it doesn't have to pass across available as the field title. I could actually, between versions of a proto file, just change the name of available if I wanted to. And as long as the type stayed the same and the ID stayed the same, then when people regenerated their client, it would carry on working. More importantly, if people accessed my new version of the service where I changed available to quantity on hand, when it deserialized at their end, it would be deserialized as available. So gRPC is really hot on versioning and compatibility between versions. It's not so hot on precise numeric types. So it doesn't have a decimal type. It has float and it has double. I am aware that that sends people screaming for the hills, particularly people who work in finance or even if you work in Starbucks and you would prefer that 5 $4.99 lattes didn't cost $24.9999999999999999999999999999. But two things. One, if you turn a decimal into a double and serialize it using Protobuf and then deserialize it at the other end and then turn it straight back into a decimal, you will not lose any precision. It will not mutate the value. The only point where doubles go wrong is when you do maths with them. So don't do maths with your Protobuf generated objects, basically, which is just good sense. The other is, if that's still not going to fly in your organization, I wrote a blog post a while ago, and I will put the link into the chat there, showing how you can create your own decimal type in Protobuf. So with some code here to represent the type, and then a partial implementation that does automatic conversion between the Protobuf type and the C# native decimal. So yes, you can get Protobuf to do decimals. It's just not built in. Okay, so now my get supplies response is just going to have a repeated supply item items equals 1. So repeated is how we do an array or a list in Protobuf, and it will essentially create a collection of type supply item in that get supplies response there. If I now save that, and then I'm just going to go into here and...
All right, so couple questions. Is there a way to port data contracts to Proto? And can you auto-generate this?
I'm so very, very glad you asked.
I'm so very, very glad that these guys asked. All I did was click. Oh, now we're talking.
So Visual Recode has been my my side project for the last 18 months. And Visual Recode is a plugin for Visual Studio that analyzes your service contracts and your data contracts and generates the proto files from them. And then it goes a step further, and it also generates the implementation of that proto service as a wrapper around your WCF service contract. There's still a lot of manual work that needs doing. You need to make sure that all your code compiles, and so the refactoring stuff and so forth. But this will take, I've run this over service contracts that were much bigger than any service contract should ever be. And it generated like 2,000 lines of Protobuf definition language. But yes, it is not open source. It is a commercial product because I had a console version, and it was really kind of shonky and it wasn't really fit for purpose. And then when it got to the point of sort of doing it as a Visual Studio extension, and people want support and they want stuff, and so I basically went to a friend of mine and said, "Hey, if I make this, can you sell it?" And so it's published by Gibraltar Software, who make VistaDB and Loop as well.
Yeah.
But yes, that will do a lot of this manually, and it will also convert duplex services. I don't think we're going to get time to look at duplex services, but we can certainly try.
But even if people download the free version, get a sense of it, and convert a few WCF services, that will teach you how what a proto file is. And then, of course, your book must go into detail on it.
My book goes into so the book explores all the types that are available, making your own types, the different patterns that WCF provides, like single duplex, full duplex, and so forth. So that's all in
just
there.
Just a time check, we're at 45 minutes.
Yeah, so I'm very, very quickly going to delete the greeter implementation here, and I'm going to comment this line out here. And then in here, I'm going to say, I'm just going to build my project quickly. And so the gRPC Protobuf code gen step is fully integrated with the MS Build process. So that has now generated me a base class. And so if I say public class supply service impler, and this inherits from supply service base. This has been generated by the gRPC compiler, and there's a whole bunch of stuff in here. Cannot navigate to it, apparently. It's hiding in the OBJ folder. But in here, I can override get supplies. And this is, so whereas with WCF, you had an interface and you implement the interface, with gRPC, you have your proto file, and then there's a compiler that compiles the proto and generates all your message types as C# classes and a base class for your service. And then you inherit from that service and override the individual methods. One of the things I really like about gRPC is that the method that you're overriding is not abstract, it's virtual. And if you don't override it, it literally throws a not implemented exception. So on the client side, they get a not implemented exception when they try and call your service, which is really nice. Certainly while you're building and testing and developing and that sort of thing. And so in here, because I updated my my supply data project, and that's Net Standard 2.0, that means that I can reference that from here as well. And then in my services, I can say services.add singleton supply data, like that, using the standard ASP.NET Core startup class. And then in greeter, let's just rename this so I don't get completely lost. And then in here, I can say private read-only supply data underscore data. And then I can initialize that field from the constructor. And so this gRPC implementation plays nicely with the Microsoft extensions dependency injection pipeline. I can inject a logger into here. I can inject all the things that I would inject into a controller or any other implementation. And then I can say var response equals new get supplies response. And I can say items equals underscore data dot get items dot select I to new supply item. And then we can just say code equals I dot code, description equals I dot description, available equals I dot available, and price equals convert dot to double I dot. Price.
All right.
That's not that. Used about where to put the semicolons, which is kind of fundamental to C#. And then we just return. We're not actually doing anything asynchronous here, so I'm just going to return task from result response like that, and that's it. Basically, I've now got my gRPC implementation of my Death Star supplies. And then if I want to access that at the other end, I can now create a new Net 5 console application. And I can call this Death Star Supply gRPC console. And we'll target Net 5 with that. And with Visual Studio, in the same way, when I was sort of knocking up this demo application, when I wanted to add the WCF service to this console application, I went to References and Add Service Reference. And in my console application here, I can go to Add Connected Service. And you see we've got service dependencies, service references, Open API, and gRPC. And so in here, I can go and I can find my proto file, which is going to be in here and in protos and supply service.proto. And say I want the client to be generated and finish that. And you see it's installing various packages that it needs. And then I can close that down and close that down. And so now we have a protos section in here. And in my console, I can say var client equals new supply service client. And I have to provide this with a channel. And so I can say gRPC channel.for address https://localhost:5001. And I'm just going to change this to be async task here. And then I can say var response equals await client dot get supplies async new get supplies request. And then I can say for each response dot items and I can do response code and response item dot description. And there we go. So it's a very similar experience to the way WCF used to be. You add the proto file, and it generates the client for you, and that's it.
We got to run it to make sure it works, though.
So we're going to run it. So let's set Death Star Supply as the startup project. There it is, and we'll run that. And it's not going to work because I've just worked out what I've done wrong. Because I've forgotten one thing. If I go back to my startup class, I haven't mapped the service, which is never going to be a good idea. So I'm going to supply service impl, so my implementation of the supply service. So then I'm going to run this. So that is running on HTTPS 5001. And then I'm going to go to the Explorer, and I'm going to just debug and start new instance of the console application. And I promise you that did work. I need to put the thing that says press a button to so console right line, press enter to exit. I do love that instruction. Press enter to exit.
Enter to exit.
It makes perfect sense to us as developers. But when you talk to other people, when you show other people that, they just go, "What is wrong with you people?" I remember having a very complicated conversation with my wife about strings, and she couldn't work out why I was talking about strings. And then it turned out after a while that normal people don't think string means a sequence of characters. They think it's this stuff that you type parcels up with.
Yeah.
Who knew? So debug this and start a new instance. And there you go. That's the gRPC console there.
All right.
So this an hour is really not a very long time.
If you have a couple questions,
okay,
good time. Can we have data objects like data set or data table in messages?
No. So I mean, as far as data table goes, you could have you define a message type, and then you have a repeated of that message type. But no, there's no kind of multi-dimensional array thing as such.
Okay.
You have to name stuff.
So can we use .NET complex types in protos?
Again, no.
Okay.
Because the Protobuf object includes the code that is necessary to serialize and deserialize it. One of the reasons that Protobuf is so efficient at the serializing and deserializing is that all the code to do it is generated as part of the build process.
Okay.
So there's no reflection going on.
Mm-hmm.
But that does mean that you can't send a complex type across.
Okay.
But what you can do, and no one can stop you, is you can serialize your .NET complex type to some kind of binary format using binary formatter or message pack or something like that. And then you can put that into a byte array.
Okay.
And then you can send the byte array. So Protobuf has a bytes type, which is basically just a byte array. And you can send that, and then you can deserialize it at the other end. That's fine. You can completely do that.
Okay.
It just doesn't have any kind of type information as it's being sent. As far as Protobuf's concerned, hey, it's bytes. But you can do it.
Right. Here's a great question from Stephen Bone. On the client side, I liked using channel factory.create channel to get an interface that can be injected using DI and, more importantly, mocked in tests. Can you do something similar in gRPC?
So there is a gRPC client factory, which you can use in anything where you're using DI. And then you can just get your gRPC client injected in the same way. And that's built on top of HTTP client factory.
Okay.
The other thing you can do is, so can I browse to the code for this? Right, here we go. So this is the generated code. And so we've got a partial class there. We've got a public partial class supply service client. Now this doesn't have an interface, but it's partial. So gRPC, all Protobuf classes are generated as partial, which means you can add whatever you want to them. And that includes interfaces. So if you say, I want this to be an interface, you can totally do that. You can basically just in a separate class define the interface for it and do public partial class supply service client : and your interface, and you can use that for cases where you need to mock things. So yes.
Excellent. All right. What else? What are other good questions?
So I can see what question.
Can I use this in a Blazor app?
Blazor is complicated.
Oh.
So the short answer is yes. The slightly longer answer is that gRPC, I should have mentioned this earlier, gRPC works everywhere except in the browser. Because it uses features of HTTP2. HTTP2 is a two-part specification. Your implementation must support this. It would be nice if your implementation supported this as well. And browsers don't support one of the features that gRPC uses. The workaround for that is that there is a thing called gRPC Web, which is distributed by Google as a Docker image, usually. And it provides an HTTP2 but browser compatible interface and then proxies on to your actual gRPC service. So it's completely transparent. But I think it's written in Go. But that obviously involves deploying an extra thing into production and managing it and all this sort of stuff. And so James Newton King, who's one of the lead developers on the gRPC.net project, went, hang on a minute, I could just do some middleware to do that. And so there is a package that you can include in your project. I think it's called so it's grpc.aspnetcore.web, I think. And then you put a using into your app.use grpc web in this thing here, and then it actually provides that gRPC web interface that will work from the browser JavaScript client, which is part of the gRPC project. But then there's also a Blazor gRPC client package, which in Blazor, it looks like the same gRPC client that I've got in my console application here. On the server, you include the gRPC web thing. And yeah, essentially, as far as you're concerned, you're using a gRPC client from Blazor exactly the same way as you would. It's just got a couple of extra steps that it's jumping through.
All right. So I think we're out of time. This has been awesome. Thanks, everybody. Is there another question?
Can I just have like 1 minute for 2 questions that I can see in the Twitch chat? Because I've got a Twitch thing going here. And Stanley was happy. Is it possible to make a .NET Microservices communicate with a microservice written in another language like Java? Yes, that is precisely what gRPC is for. That is the point. You can generate, you publish your proto file, and then people can create Rust clients, Go clients, Python clients, Java clients, Node. So from Node, it will just work. It's just the browser that JavaScript doesn't work. So yes, that is what this is for. And then Wasabi Dev, if you had multiple gRPC services in a project, would you just add more map gRPC service lines in the startup? Again, yes. So yeah, you can have as many as you want in a single project. Purists would say you should have each one should be in its own console application and deployed in its own Docker image and run in its own process. But we're not all purists. Oh, and one final caveat.
Yes.
You can't run it on IIS.
Can't run it on IIS.
Can't run it on IIS. You will be able to. It's the same thing. IIS doesn't support all the HTTP2 features that are required. But you can run it natively. You can run it as a Windows service. So it hooks in with Windows Service Startup. Or you can run it on Linux in a Docker container, in a Kubernetes cluster. gRPC and Kubernetes go together like rice and beans. It's what they're made for.
Perfect. Thank you so much, Mark.
Well, thank you, Stanley. Appreciate
I think
it.
Maybe a little bit down the road, we have you come back. We do some more advanced scenarios, but this was a really nice introduction to what this is. And I think it was really helpful to get people started in how to use this stuff. So thank you so much.
Can I plug my Twitch stream?
Of course.
It competes with yours on a Tuesday, so I might change the time. But yeah, I stream on Twitch, and at the moment I'm learning Blazor and making a thing that does overlays and sound effects on my Twitch stream using Blazor. But I also talk about sort of .NET stuff, and we did a thing to help you upgrade web forms applications to ASP.NET Core and stuff. So drop by there and give me a follow. Be much appreciated.
All right. Thanks so much. Thanks everybody for watching, and we will see you next time on Visual Studio Toolbox.
Cheers, everyone.